everyone. We're doing a deep dive today, and I'm so excited for this one.
Me too.
This is all about systems of equations.
Yes.
And I'm filling in for Kareem.
Oh, very cool.
So, I'm excited to talk about this.
Yeah.
'Cause this is one of those things that people hear and they kind of freak out a little bit, right?
Right.
Systems of equations.
Yeah, sounds
very
intimidating.
It sounds intimidating.
But they're really a fundamental concept in math.
Right.
And once you get the hang of them, they can actually be quite interesting.
Yes. And not only that, but they're actually really practical.
Oh, for sure.
And they can be used to, solve all sorts of problems.
Absolutely.
So we're going to talk about that today.
Awesome.
So, when you were in middle school,
Yeah.
you probably remember those word problems.
Yeah.
Where you had to figure out, like, how many apples John had if Mary had twice as many.
Right.
And, you'd have to set up an equation.
Yeah.
And, solve for X.
Exactly.
Well, systems of equations are basically a way to solve those kinds of problems.
Yeah.
But instead of just one equation, you have multiple equations.
Right.
And you have to solve for multiple variables.
That's it. That's the key.
Yeah.
You've got more than one equation and you're dealing with more than one unknown.
Right.
And that's where the system comes in.
Exactly. And it's like a puzzle.
Yeah.
You have all these different pieces of information,
Uh-huh.
and you have to figure out how they all fit together.
So you got to put those pieces together.
Exactly. So how do we actually solve these systems?
So there are a couple of different ways.
Okay.
You can use substitution. You can use elimination.
Right.
But today we're going to focus on the graphing method,
Okay.
which is really cool because it's very visual.
Yeah.
So you can actually see what's going on.
I like that.
Yeah, it's a very intuitive way to understand it.
Okay, so let's talk about graphing.
All right.
Where do we even start?
So the first thing you need to do is to understand that each equation in the system represents a line
Okay.
when you plot it on a graph.
Got it.
And the solution to the system is the point where the two lines intersect.
So it's like X marks the spot,
Exactly.
but instead of a treasure map,
Right.
it's the point where the two lines cross.
That's your treasure.
That's the treasure.
The solution.
That's so cool. I
Yeah.
never thought of it that way.
It's pretty neat.
So we're looking for the point of intersection.
Right.
But what if the lines don't intersect?
That's a great question.
Yeah.
So if the lines are parallel,
Okay.
that means there's no solution
Oh.
because they'll never intersect.
All right.
And if the lines are the same,
Okay.
that means there are infinite solutions.
Oh, wow.
Because they're essentially the same lines.
So it's like three different scenarios.
Exactly.
You'd have one solution,
Right.
no solutions,
Uh-huh.
or infinite solutions.
That's it.
That's amazing.
Yeah, it's pretty cool.
Okay, so can you give us an example
Sure.
of how to actually graph a system of equations?
Absolutely. So let's say we have the system of equations y equals x plus 1 and y equals x plus 3.
Yep.
So to graph these equations, we can start by picking a few x values and then calculate the corresponding y values using each equation.
Okay.
So for example, if we plug in x0 into the first equation, we get y1.
Okay.
And if we plug in x equals 1 into the first equation,
Yeah.
we get y2.
Got it.
So we have 2 points now,
Okay.
0, 1, and 1, 2.
Right.
And we can plot those points on a graph,
Okay.
and then we can connect the dots to draw the line.
Got it.
We can do the same thing for the second equation.
Okay.
So if we plug in x0 into the second equation, we
Yeah.
get y3.
Okay.
And if we plug in x equals 1 into the second equation,
Uh-huh.
we get y2.
Got it.
So we have 2 more points, 0, 3, and 1, 2.
Right.
We can plot those points on the graph
Okay.
and connect the dots to draw the line.
And then we look for the point where the lines intersect.
Exactly. And in this case, the lines intersect at the point 1, 2.
So that's the solution
That's it.
to the system of equations.
That's the solution to the system.
That's so cool.
It's pretty cool, right?
It's like magic.
It is a little bit like that.
Yeah, you just plug in a few numbers,
Uh-huh.
draw some lines,
Right.
boom, you have the answer.
There it is.
That's amazing.
It's a powerful tool.
So we've talked about how to graph systems of equations.
Yeah.
And we've talked about the different types of solutions.
Yes.
But how is this actually used in the real world?
Oh, man, in so many ways.
Give us some examples.
Okay, so in economics, for example,
Yeah.
systems of equations can be used to model supply and demand.
Oh, interesting.
So, the supply curve
Mm-hmm.
shows how much of a product producers are willing to sell
Right.
at a given price.
Okay.
And the demand curve shows how much of a product consumers are willing to buy
Got it.
at a given price.
Okay.
And the point where those two curves intersect, that's the equilibrium price.
Oh, wow. So it's like the same concept
Exactly, it's the same concept.
as finding the solution to a system of equations.
That's right.
That's amazing.
And engineers use systems of equations all the time, too.
Oh, really?
Like for designing bridges and buildings,
Wow.
they need to make sure that the structure can withstand all the different forces that are acting on it.
Right.
And they use systems of equations to model those forces.
That's incredible.
Yeah, so you can see that systems of equations are a really powerful tool
Absolutely.
for solving all sorts of real-world problems.
Well, I think we've covered a lot of ground today.
I think so, too.
We've seen how graphing can make systems of equations much easier to understand.
Definitely.
And we've seen how they're used in different fields like economics and engineering.
For sure.
So if you're ever feeling lost in the world of math, just remember that systems of equations are here to help.
Absolutely.
They're a powerful tool that can help you solve all sorts of problems,
That's right.
and they're not as scary as they seem.
Not at all.
Once you get to know them,
They're actually pretty friendly.
they are pretty friendly.
Yeah.
So I'm curious, we talked about graphing as a way to solve systems of equations.
Yeah.
But are there other ways to solve systems of equations without graphing?
Yeah, definitely. There are a couple other algebraic methods.
Okay.
There's something called substitution,
Okay.
and then there's also elimination.
Interesting.
Yeah. So maybe that's something we can dive into another time.
I would love that.
Yeah.
But until then, keep those equations flowing.
Absolutely.
Thanks for listening.